Okay, so now I'm going to have a look at more complex numbers, and we're just going to have a look at multiplying and dividing complex numbers. Um, so first thing I'm going to do is just have a look at multiplying complex numbers by I and minus I. So if we take, again, we'll just take the complex plane here. So if we take the real axis and the imaginary axis here, so we'll just go 1, 2, 3, 4, 5. Again, -1, -2, -3, -4, -5 in that direction. Here we've got I, 2I, 3I, 4I, and then along here we're going to end up with -I, -2I, -3I, -4, 4I, and so on. So let's have a look at some complex numbers, and we'll just multiply them by I and minus I. So let's have a look at first one. Then we look at is, let's say, Z1, and let's say it's 2 plus 3I. We'll say 2 plus 3I. Now I'm going to multiply Z1 by I. In other words, what I'm going to do is do I times Z1. So that's just I times 2 plus 3I. When you multiply that out, you get I times 2 is 2I. I times 3I is plus 3I squared. Now, I squared is minus 1. Remember, I is the square root of minus 1. So I squared would be the square root of minus 1 all squared, which is just minus 1. So here I'll end up with 3 times minus 1, which is minus 3. So I'll end up with minus 3 plus 2I. So the I squared becomes minus 1, so this becomes minus 3. So I've just put that first, I've switched them around. I'm going to put the plus 2I second here. So if I plot that, then we'll plot these. Let's see, I started with 2 plus 3I, so there's 2 plus 3I, so that's my Z1 there. Now I've multiplied that by I, and I've ended up with minus 3 plus 2I, minus 3 plus 2I. So this is I times Z1. So what's that actually done to my complex number? Well, if you take this distance here again from the origin, and you look at this distance here from the origin, what you'll actually find is that that angle there is 90 degrees. So what I've done is I've rotated this complex number 90 degrees anti-clockwise. So when you multiply by I, you rotate the complex number 90 degrees anti-clockwise. What happens then if I multiply by minus I? So again, we have our Z1 here, so I'm going to multiply that by minus I times Z1. That gives me minus I times 2 plus 3I. So that gives me minus 2I. And then minus times plus here is minus. And I times 3I is 3I squared again. That will give me, remember this I squared here is minus 1. So minus times minus is plus. So this 3 here becomes plus 3. So I end up with 3 there. And minus 2I here as well. So I end up with 3 minus 2I. 3 minus 2I is 1, 2, 3. Minus 2I is down here. So this is minus I times Z1. So what's actually happened here is I've rotated Z1 90 degrees. Again, this is 90 degrees here. I've rotated Z1 90 degrees clockwise. And that's your general rule. If you multiply a complex number by I, you rotate the complex number 90 degrees anti-clockwise. If you multiply by minus I, you rotate the complex number clockwise 90 degrees. Okay, so let's have a look at multiplying one complex number by another complex number. So let's take let's say 2 plus 7I, and we're going to multiply that by 3 minus 5I. So all you've really got to do here is do exactly the same as what you do in normal algebra. You multiply the 2 by the 3, the 2 by the minus 5i, the 7i by the 3, and the 7i by the minus 5i. So in other words, what we're actually doing is taking the 2 and multiplying it by 3 minus 5i, and then we're taking the plus 7i and multiplying that by 3 minus 5i. So when you do that, you get 2 3s are 6 minus 10i plus 3 7s 21 I here, and then plus times minus is minus, 5 7s 35, and then I times I squared. So what you end up with here is 6 minus 10i plus 21, that gives me plus 11i. And then you've got the minus 35i squared. Remember, I squared is equal to minus 1. So this is just minus 1. Minus 1 times minus 35 is plus 35. So that gives me 6 plus 35, which is 41, plus 11i. So when I multiply these two complex numbers together, I get 41 plus 11i. So it's fairly straightforward. You just simply do exactly what you do when you're doing normal algebra. Okay, so that's multiplying complex numbers, one complex number by another. Let's look at division of complex numbers now. So if you take, let's say, we'll just divide first of all. Let's say you take 15 plus 10i, so it's just 15 plus 10i, and we want to divide that by 5. Well, you can do again what you do in normal kind of algebra. You can take the 5 and divide it in here, the 5 divided in here, so you end up with 15 over 5 plus 10 over 5i. That just gives you 3 plus 2i. So that's straightforward enough. You're just dividing by a real number here. Now, just before I get on to dividing, you say I divide one complex number by another complex number. Just before I start that, I just want to talk about what's called the conjugate. The conjugate of a complex number. So the conjugate of a complex number, it sounds complicated. It's not very complicated at all. So if you take z1, for example, is 3 plus 2i. The conjugate of this here, you write it like this, z1, and you put a little bar over the top. So z1 conjugate is equal to just simply 3 minus 2i. All you've got to do is change the sign of the imaginary part. So it sounds complicated. It's just very, very simple. You just simply change the sign, whatever is in front of the imaginary part. So if you take another complex number, minus 5 minus 2i, the conjugate then of that, the complex conjugate of z2 is just simply minus 5 plus 2i. Okay, so that's the conjugate of a complex number. So we're going to use that when we divide complex numbers. So let's take a couple of complex numbers and divide them and see what happens. So let's take let's say 5 minus 5i, and we're going to divide that by 2 plus I. Okay, so what you do here is you take the denominator, which is 2 plus I, you get the conjugate of it, which is 2 minus I, divided by 2 minus I. You multiply all of this here by your complex number division, your division here, your quotient. So really 2 minus I over 2 minus I is 1. So all we're really doing is multiplying all of this by 1. When you multiply anything by 1, you don't change it. So all of this here is exactly the same as our original division here, because all we're doing is multiplying by 1. So what you'll find when you multiply the bottom part here out, the i's will disappear. And that's what you're hoping for. If you end up with an I on the bottom, you've done something wrong in your calculation. So let's see what happens here. So what we're going to do is multiply the top by the top and the bottom by the bottom. So let's do that out. So the top by the top is just going to be 5 times 2 minus I minus 5I times 2 minus I. And then on the bottom we end up with 2 times 2 minus I plus I times 2 minus I. Okay, so let's do all that out and see what happens. So 5 times 2 on the top here we get 10 minus, and then 5 times I is 5I, minus 2 5s here is 10I, then minus times minus plus, 5 times 1 5, I times I squared. And then on the bottom 2 2's 4, minus 2I, and then here plus 2I, and then minus I squared. So we should find that the i's will disappear on the bottom. Let's see, do they? So on the top we end up with 10, and then we've got minus 5i minus 10i, that gives me minus 15i. Now remember I squared here again, I squared is just minus 1, so this here is just minus 1. Minus 1 times plus 5 is minus 5. Now on the bottom here the denominator is 4. Minus 2i plus 2i will give me 0, so these two here will just cancel each other out. And here I've got minus I squared. Remember, I squared is minus 1, so minus minus 1 is plus 1. Okay, so we got rid of all the i's on the bottom, that's perfect. On the top we end up with 10 minus 5, which is 5, minus 15i. On the bottom we end up with 5. So that's perfect. That just gives me 5 over 5 minus 15 over 5i, which is just simply 1 minus 3i. So when we divided these two, this is what we started with here. Just this little bit here is what we started with. We multiplied it by 1 in the form of 2 minus I over 2 minus I, and we got rid of the i's on the bottom, on the denominator. We got rid of the i's on the bottom eventually, and we ended up with 1 minus 3i. And that's how you divide complex numbers. You just simply look at whatever's on the bottom of your fraction, your denominator, get the complex conjugate of it, in other words change the sign of the imaginary part, divide it by itself, and then multiply by your original division, and you should find that the i's will disappear. As I say, if you do end up with an I on the bottom, you've done something wrong somewhere. And that's it for that.